In question 9, functions f and g are defined by f of x equals to x squared minus 4x plus 3 for x greater than c, where c is a constant, and g of x is 1 upon x plus 1 for x greater than minus 1. In part A, we have to express f of x in the form x minus a whole squared plus b. So we can use the complete, we have to convert this into the complete square form. So we can use the comparison method over here to convert the equation, which is x squared minus 4x plus 3, and we can write this in the expanded form. So this will become x squared minus 2ax plus a squared plus b. To find the values of a and b, we can compare the coefficients of x on the left and the right hand side. So on the left hand side, it is minus 4. On the right hand side, it is minus 2a. So minus 2a, we can write it as minus 4. And a will be equals to positive 2. To find the value of b, we can compare the constant terms. So on the left hand side, it is 3, and on the right hand side, it is a squared plus b squared. The value of a is 2, so this will become 2 squared plus b squared equals to 3, and b squared will be equals to 3. So this will become 3 minus 4, and b squared will be equals to, and this is not a b squared, this is just a b, so this will be a squared plus b. So a squared plus b is 3, so b will be equals to minus 1. Once we have the values of a and b, we can write this as x minus 2 whole squared minus 1. In part B, it says it is given that f is a one-to-one function. We have to state the smallest possible value of c. Now, for a function to be one-to-one, it means that it can only have one value of x for one value of y. And from the previous part, we know that the turning point is at 2 and minus 1. So the smallest possible value for this function to be one-to-one, and we know that x is greater than c. So this means that it has, for it to be a one-to-one function, the quadratic graph must start from this point, and it will be like this. So the smallest possible value will be x will be equals to 2, or we can write c will be equals to 2. And if there was any other value lesser than 2, the graph will not be one-to-one as it will be going upwards. So for each value of y, we'll have more than one value of x. So the only possible smallest value is c will be equals to 2. In part C, it says that it is now given that c equals to 5. Find an expression for f inverse and state the domain of f inverse. So to find an expression for f inverse, we have to first convert our function into the full square form, which we already did in part A. So that was x minus 2 whole squared minus 1. To find the inverse, first we'll write y over here and write this expression as it is. Now exchanging the values of x and y, so this will become x is equals to y minus 2 whole squared minus 1. Taking 1 on the left hand side, so this will become x plus 1 is equals to y minus 2 whole squared. Taking the square root on both the sides, so we'll get the square root of x plus 1 equals to y minus 2. Taking 2 on the left hand side, we'll get y is equals to 2 plus square root of x plus 1. So finally, we can write the expression for f inverse of x as 2 plus square root of x plus 1. Now to find the domain for f inverse, so for a function f of x, the range is equal to the domain of the function. So first we can find the range of the function f of x. Now, as the value of c is 5, or c is the value of x, so finding the range of f of x, that will be, so substituting x equals to 5, we'll get 5 minus 2 whole squared minus 1. So f of x will be equals to 5 minus 2 is 3, 3 squared is 9, so 9 minus 1 is 8. So we can write that f of x will be greater than 8. So as the range of f of x is greater than 8, it means that the domain of f inverse will be also be greater than 8. So we can write it as that the domain for f inverse will be x greater than 8. In part B, it says find an expression for gf of x and state the range of gf. Now to first find the function g of f, we will substitute in the function g. In place of x, we'll write the whole function f of x. So the function g was 1 upon x plus 1. So we'll write it as 1 upon x plus 1, and in place of x, we'll write the function f, which is x minus 2 whole squared minus 1, and this was plus 1. So this will be a plus 1 up here. minus 1 plus 1 becomes a 0. So the expression for g of f of x will be 1 upon x minus 2 whole squared. Now to find the range of g of f, what we first must understand is that in the function g of f, in place of x, we have the values of f of x. So, and f of x was x is greater than c, and for g of x, x was greater than minus 1. So we can see that this function f of x must be greater than minus 1. So the function f of x was x minus 2 whole squared minus 1, and as the domain for g of x was x greater than minus 1, so we can write that this will be greater than minus 1. So solving this equation, we can write it as x minus 2 whole squared will be greater than, so my 1 will go on the right hand side, this will become minus 1 plus 1. So this will be x minus 2 whole squared, and that will be greater than 0. So the values of x will be 2 and minus 2 up here. But over here in this case, we also have to take in the consideration the values of f of x. Now f of x, we know that it had to be greater than c. And the function g of f was 1 upon x minus 2 whole squared. So taking values of x for g of x which were greater than minus 1. So if we substitute minus 1 up here, so let's say if I substitute x equals to minus 1 up here, this will be 1 upon minus 1 minus 2 whole squared. And this will be equals to 1 upon 3 whole squared, which is equals to 1 upon 9. Now, as I keep on increasing the values of x over here, and we know that the function g of x again should be greater than minus 1. Now, x is greater than minus 1 basically means that x could be anything above minus 1, which is 0, 1, 2, 3, 4, and so on. Now, as I keep on increasing the values of x, the value for the denominator will keep on increasing, and 1 upon a very high value will basically become a 0. So the maximum value for g f of x that we can get over here is 1 upon 9. Any other value of x that we substitute over here will give us a value which is less than 1 upon 9. And a very huge value of x will give us a value which is near 0, but it will not be equal to 0. So the range for g f of x will have to, it will be greater than 0 as it can never reach 0. X can be infinity at the point where g of f of x will become a 0, and the maximum value for g of x will always be 1 upon 9, as x has to be greater than minus 1 for g. So even if we take these values of f of x, they will give us the value x equals to 2. But solving this separately, as even if we substitute 2 over here, that will become 2 minus 2, which is a 0. So 1 upon 0 will become an infinity, which is basically not possible for g f of x. The maximum possible value it can take is 1 upon 9. So the final answer for the range of g of f of x will be equals to greater than 0 and less than 1 upon 9.